Hi, everybody. Welcome back. So, this is the third session of chemical kinetics. And in the previous section, we discussed a term which is called the order of the reaction. And today we'll be diving into deeper concepts of different orders of reaction. Okay. So, before proceeding, there was a homework regarding the unit of the rate constants if the values of n are A, B, C, D as follows. Okay. So, let's try. So what did we say yesterday? That rate of reaction is proportional to the active masses of the reactant raised to some power, and the proportionality sign is compensated by proportionality constant, and this constant is named as the rate constant. Rate constant. Now, if we have to find the unit of the rate constant, K, which is equal to unit of the rate, which is moles per liter, divided by unit of the concentration. Sorry, units of rate is moles per liter per second. Moles per liter per second. And units of concentration, moles per liter raised to n times. Right? And we got a general formula as moles per liter raised to 1 minus n per second. This is the general equation for the unit of rate constant. So let's try one by one. A, if you put the value of n as equal to 1 by 2. So what will be the equation? Moles per liter to the power 1 minus 1 by 2 per second. What is 1 minus 1 by 2? 1 minus half is half per second. Now, if you want to take it inside, note that a to the power m raised to n. Okay, that is a to the power m into n. So here you have mole to the power 1 raised to 1 by 2. When you open the brackets, it will become mole to the power 1 by 2, L to the power minus 1 by 2. Why? Minus 1 into 1 by 2 is minus 1 by 2 per second. Per second. That's it. Yeah. B. What was the order? Order is minus 1 by 2. We did discuss yesterday that order of the reaction can be any whole number, meaning 1, 2, 3 or 0 also. It can be negative and it can be fractional as well. So now when you put the value of minus 1 by 2, what are we going to get? We'll get moles per liter to the power 1 minus n. And the value of n is already minus 1 by 2 per second. Now this adds up, right? Minus minus becomes plus. So this becomes 1 plus 1 by 2, which is equal to 3 by 2. Moles per liter to the power 3 by 2 per second. Now, if you want to expand this, mole to the power 3 by 2, liter to the power minus 3 by 2 per second is going to be your answer. Okay. Next one. Value of n, that is order of the reaction, is fractional again. N is equal to 1 by 3. N is equal to 1 by 3. So let's try. Moles per liter to the power 1 minus 1 by 3 per second. 1 minus 1 by 3 is 3 minus 1 by 3, which is 2 by 3. So I'm skipping one step. I'm opening the brackets directly. Mole to the power 2 by 3, liter to the power minus 2 by 3 per second. Yeah, I hope you're getting it along. D. Value of n was equal to minus 2 by 3, right? Yeah, minus 2 by 3. Let's give it a try. It's moles per liter to the power 1 minus 2 by 3 per second. And what is 1 minus 2 by 3? This will become 1 plus 2 by 3. And when you take the LCM, this becomes 3 plus 2 by 3, which is equal to 5 by 3. Easy. Now, when you open the brackets, moles to the power 5 by 3, liters to the power minus 5 by 3 per second. So, this is how you find the units of rate constants if order of the reaction is given. If order of the reaction is given. So, this is very important. Why? Because in certain questions, okay, for example, just a sample question, okay? What they will mention is you have so and so reaction and they'll give you many values. Okay, you have to find the integrated rate equation, time at which the equilibrium is attained, so and so. A jargon question. But they won't mention the order of the reaction. Instead, if they provide the value of rate constant along with its units. Along with its units. What can be done? Even if the order of the reaction is not mentioned, you can find out what the order is. Correct? You can do it now. If they say that there is a reaction A plus B giving P, where the rate constant is equal to 5 into 10 to the power minus 3 per second. Let's say only this much is given in the question. Only this much is given in the question. And then they have asked some parameters which is to be calculated. How can you find the order of the reaction? Very easy. Unit is given per second. Per second. And this was done yesterday. If the unit of rate constant is per second, then the order of the reaction is equal to 1. Correct? So this can be found if they provide the value of if they provide the value of the rate constant along with its units, order of the reaction can be determined. Okay? It can be found very easily. Note. Okay? This will come out with practice. Don't worry. I'm just writing this as a note so that you will be more aware when you see questions. All right. Now we have learned the definition of what order is. What are the cases where order can be equal to molecularity? We did discuss yesterday that there are certain reactions which are called elementary reactions. I'm not going to explain that again because I took a lot of time to explain it in the previous session. Do revise the previous sessions before attending every new session. Okay, that was discussed and we have kept it aside. Now today we'll understand the deeper meaning of what order of the reaction is. So we'll do a couple of questions before that. If order of the reaction, please note it down. If the order of the reaction N is equal to 0, okay? If N is equal to 0, the expression is going to be R is equal to rate constant into, let's say we have a model reaction where A becomes products. So R is equal to rate constant into concentration of A to the power N it is. But here it will become to the power 0 because the order is 0. We have considered the order of the reaction to be 0. Now listen carefully. Let's say that I increase the concentration. I increase the concentration of the reactant to 2A times. Now what will be my expression? R is equal to rate constant into 2A to the power 0. But when I am multiplying the concentration 2 times, when I'm multiplying the concentration 2 times, is there any difference that is going to appear in the rate of the equation? So see, now my rate has changed to, so this was, upon simplification, this is just R is equal to K. Because any number raised to 0 is 1. Okay. Now, when you increased the concentration, when you multiplied the concentration by 2, Now the expression is R is equal to K into 2 times the concentration to the power 0. And effectively, what is that equal to? R is equal to K again. Why? Because any number raised to 0 is 1. Now let's say that I increase the concentration by 3 times. R is equal to K into 3A to the power 0 it becomes. I have increased the concentration 3 times. Does that make any change to the rate of the reaction? No. No. Which means R is again equal to K. So consistently, any changes in the concentration of the reactant in a zero order reaction does not change the rate. Did you get the point? Or what I can say is rate of a zero order reaction. Rate of the zero order reaction is independent, it does not depend, right? Independent on the concentration of reactant. Very important. So whatever changes that you make in the concentration of the reactant, whether you multiply it, whether you divide it, that's not going to have any effect on the rate of the reaction if the order of the reaction is 0. Okay, let's try another one. If the order of the reaction is n is equal to 1, let's say. So this is a topic where you get many questions. So be thorough with the concepts so that you can crack it easily. So what would be the equation? It will be R is equal to K into concentration of A to the power 1. It does not matter even if you write 1 or not. It's understood. So R is equal to K into concentration of A it is. Now let's say that I'm doubling the concentration of the reactant. What happens? It becomes rate of the reaction. Now the expression, the new rate after doubling is K times 2A, because now I have doubled the concentration. Now can you see how is it related to the earlier rate? Can you find it out? Let's say my new rate is R prime and I take this 2 outside and Ka. I can write it like this as well. 2 is a constant. I can take it outside. And what is this equal to? Ka equal to? K into A is same as R. K into A same as R. I can substitute it over here. Which means my new rate is equal to 2 times my earlier rate. My new rate is 2 times than that of the earlier rate. Which means, understand, when I increased the concentration of the reactant 2 times, my rate also increased or multiplied by 2 times. Let's do one more. Let's say that you increase the concentration 3 times. Do it on your own. Let's say I have R double prime, which is going to be equal to K into concentration is increased 3 times. 3 is a constant. I can take that outside. K into A, as previously known, this is equal to just R, the rate of the initial reaction. So can you see, when you increased the concentration 3 times, rate has also increased by 3 times. When you increased the concentration 2 times, rate has also multiplied 2 times. Easy relation, which means if concentration of the reactant, or in our case it is A, whatever is understandable to you, you can note it down. If concentration of the reactant is increased n times, or if it is multiplied n times, now this is a symbol that I use to write increased. Please don't get confused. If you wanted to write in words, write down in words. If the concentration of the reactant, is multiplied to n times rate of the reaction also multiplies by n times. Easy. Because it depends on a power of 1. Very easy. One more general expression and then we'll be moving to the questions. Okay? If order of the reaction is, let's say, n is equal to 2. If order of the reaction is n is equal to 2. Now, try it on your own. Let's say my expression is R is equal to K times concentration of A to the power 2, right? Because now the order of the reaction is 2. Let's take two cases. One case is where my concentration of A is doubled, and the other case is where my concentration is tripled 3 times. So what would be the new expressions? R prime is going to be equal to K, concentration of the reactant is now 2 times A to the power 2, correct? Now 2 square is 4. 4 is a constant. I can take that outside. R prime is equal to 4K concentration of A to the power 2. Now I already know that K into A square is equal to R, and I can substitute it over here. R prime is equal to 4 times R. R prime is equal to 4 times R. Right? So when you increased the concentration 2 times, your rate has become 4 times. Okay? You will get a relation when you do the next example. So here, R double prime is equal to K times concentration has now become 3A to the power 2. 3 squared is 9. 9 can be taken outside. Ka squared. Correct? Now, Ka squared is same as R. So, 9 times R. So, can you see? When you increased the concentration by 2, your rate has become 2 square, 4. When you increased your concentration 3 times, your new rate has become 3 square times, 9. Easy? So, if you increase your concentration in a second order reaction, if concentration of the reactant is multiplied to n times, rate is multiplied by n to the power 2 times. Because it is a second order reaction. Earlier, it was a first order reaction. Okay? So this is a general expression and the concept behind what the order of the reaction is. Let's do some sample problems so that you will get a better understanding. Okay. Let's do it. Question number 7 of chemical kinetics. Question number 7. Very good question. Note it down. In a particular reaction, if volume of the vessel V is decreased to 1/3 and rate is increased 9 times, what is the order? What is the order of the reaction? Note down the options: 0, 1, 2, and 3. Okay. So whatever concepts that we learned were based on the concentration. Instead of changes in the concentration, what they have given is in terms of changes of volume. Now we have to know how is concentration volume related. Very easy. We do know that concentration is equal to number of moles per volume. Right? What is the unit of concentration? Moles per liter. Correct? So how are they related? Concentration and volume are inversely proportional. Concentration volume are inversely proportional. So if they say that your volume has changed 1 by 3 times, so they have given that the volume has changed 1 by 3 times, it means just the ulta, the opposite, the reciprocal. So volume has changed 1 by 3 means your concentration has changed 3 times. So concentration has changed 3 times. How did we get this? 1 by 3 changes of volume means the reciprocal changes of concentration. See, they are inversely proportional. They are inversely proportional, right? So if the concentration has changed 3 times, the rate has changed 9 times. How are they related? Very easy. Changes of the rate 9, changes of the concentration 3. Now we have already done this over here. When the concentration changes by 3 and the rate changes by 9, they'll be related by second order reaction, and the correct option is C. Right? 3 square times is 9. So it's a second order reaction. The only takeaway from this question is the questioner does not always ask in the terms of concentration. They might also give it in terms of volume. And we know that concentration and volume are inversely proportional. That's it. Okay? One more question. Question number 8. For the conversion of x giving y, it is given that it follows second order kinetics. Oh, for this reaction, concentration of X is increased by 3 times. And volume of the vessel is decreased by 1 by 2. The rate of formation of Y is option A, 9 times, option B, 18 times, option C, 27 times, option D, 36 times. Very easy question, just a combination of both concentration as well as volume, that's all. Okay, so let's try. It's already given in the question that it's a second order kinetics. And they have asked for the rate of formation of Y. So let's write down the rate of the reaction first. Rate of the reaction is equal to minus dx by dt, and that is equal to plus dy by dt. So meaning rate of the reaction is equal to dy by dt, which is same as rate of formation of Y. So we have learned the differences between rates of formation and rates of reaction. Here, as the coefficient is 1, it does not make any change. Okay, so what we have to find is rate of the reaction only. They are the same. Okay, now it's given that it's a second order kinetics, correct? And there are two things happening. One thing is your rate is actually K into concentration of X to the power 2. This is going to be your expression because it's a second order kinetics. So first what they do is they are increasing the concentration 3 times. Correct? So when you increase the concentration 3 times, by this time you know that the rate will increase by 9 times. So this is the new rate. So by just increasing the concentration of X by 3 times, your rate will change by 9 times. That's known. Now they're saying that along with the change of concentration by 3 times, they are also reducing the volume to 1 by 2. Okay. So reducing the volume to 1 by 2, we know that volume and concentrations are inversely proportional. So volume is reduced means concentration is increased. Concentration is increased by 2 times. Concentration is increased by 2 times. Correct? So this is there. And along with that, we know that K, it is X squared. And now, depending on the vessel, volume of the vessel when reduced to half, concentration increases 2A times. And this is going to be 4Ka square, which means 4 times the initial one. So by just increasing the concentration by 3 times in the question, the rate changes by 9. And by changing the volume, it changes by 4. Now this is happening together. So what you have to do is you have to multiply. It's happening together. Okay. So it's going to be 9 into 4, which is equal to 36 is the correct answer. Option D. 36 is the correct answer. Okay, so whatever changes that you bring in the concentrations, it will get multiplied in the rate. Do not add them up, okay? You have to multiply. See, whatever we are doing is getting multiplied, right? 3 times increase, 3 into 3 raised to 2. It gets multiplied. So, here, there are two changes happening. One is the changes of the concentration, which increases the rate by 9. And the other one is the changes of the volume, which increases the rate by 4. And altogether, it is 9 into 4, 36 is the correct answer. 36 is the correct answer. All right. Next question, very good question. Mark this as important. Question number 9. Question number 9. For X times A giving Y times B, X times A giving Y times B, they have given log of minus dA by dt is equal to log of dB by dt plus 0.3. X and Y are option A 2, 1, option B 1, 2, option C 1, 4, option D 4, 1. Very good question. This type of question has not been asked in the competitive exams. This is taken from old question papers of JEE, but it's very good one. I think it was asked in JAM once. Okay, yeah. So how do we do it? How do we do this? How do we approach the question? Look what is given. There is some reaction which is given. Okay. And we can see that there is minus dA by dt, and we can see there is plus dB by dt. And you know what that is, correct? When do we get minus dA by dt and plus dB by dt? When we write the expressions of rate of the reaction, and they have taken logarithms. So this is the idea that we get by looking at the question. Let's try to do it. Let's try to derive it. So let's write the rate expression first. Rate of the reaction is equal to 1 by x minus dA by dt equal to 1 by y plus dB by dt. Okay. I'll take x to the other side. So minus dA by dt is equal to x by y dB by dt. Okay. So I have got this much. Minus dA by dt is there. Minus dB by dt is there. Okay. I have got something. Now I need logarithms. So let's take log on both sides. So when you take log on both sides, this becomes log of minus dA by dt, which is equal to, now see, this is a product, correct? So let's say this is A and let's say this is B. X by y is A and dB by dt is B. Understand that log A into B is log A plus log B. You have to know this, okay? Similarly, log A by B can be written as log A minus log B. These basic logarithmic relations you should know. All right. So now if I take, so this is A into B, and if I write it in that terms, I can write it as log of dB by dt plus log of x by y, correct? Now look into the reaction which is given. On the left, what you have is log minus dA by dt. Here also we have log minus dA by dt. Here I have log dB by dt. Here also I have log dB by dt. Now what is given? Here there is 0.3. Instead what we have is log x by y. So what we get is log x by y is equal to 0.3. Now you have to find the value of x by y such that log of that value is 0.3. Okay. And through consistent practice, you will get to know the basic values, at least learn the log values up to 10 so that you can be quick enough. Okay. You have to learn at least the first 10 values, log 1, log 2, log 3, log 4, log 5, log 6, log 7, log 8, log 9, log 10, at least. Others you can derive. Okay. So this is log x by y is equal to 0.3, and you have to know that log 2 is equal to 0.3. Otherwise, you can use calculator as well. We do have access to calculator, so you can do that as well. How to do that? You have to take the anti-log, right? X by y. So anti-log on this side, right side becomes 10 to the power 0.3. Okay. I hope you know how to take anti-log. Let's say you have log x is equal to y. Anti-log on both sides means x is equal to 10 to the power y. Same. So when you do this in calculator, x by y raised to 10 to the power 0.3, you will get 2. Which means x by y is equal to 2. Which means x is equal to 2 and y is equal to 1. Is there an option like that? Option A. X is equal to 2 and y is equal to 1. Very good question. A very good question. Okay. Next question will be your homework. Question number 10. Question number 10. The correct statement correct statement among the following is? Among the following. All right, option A. Rate of the reaction can be positive, negative, or zero. Option B. Units of rate of reaction depends on order of the reaction. Option C, average rate and instantaneous rates can be equal. Option D, rate of reaction is constant. With changes of concentration in a first order reaction. In a first order reaction. Okay. Okay, we'll discuss over here itself. No need to do this as homework because there is one option that needs a little bit of explanation. Okay, now you can approach this question by cancelling out the option and then you can come to the final answer. I know that these terms, average rate and instantaneous rate, might be new to you. But then even if you don't know these terms, you can cancel out the options and then you can come to the final answer, which is one among the approaches that you have to adapt in competitive examinations. For example, let's look at option A. What is given? Option A. Rates of the reaction can be positive, negative, or zero. Is that statement right? No. This is wrong. What is the correct statement? Rates of the reaction is always positive. Always positive. Order of the reaction can be positive, negative, or zero. Okay, so pay attention. Option B. Units of rates of the reaction depends on the order of the reaction. Is that true? No. The units of rates of the reactions are always moles per liter per second. Rates of the reactions units will never change. What changes with the order of the reaction? Units of rate constant, not the rate. So you have to be very careful with the terms, whether it is rate or whether it is rate constant, whether it is order of the reaction or rate of the reaction. Pay attention. Okay, C is something that you don't know. The terms might be new to you. So let's leave that for the time being. Option D, rate of the reaction is constant with changes of concentration in a first order reaction. Is that true? No. That's not true, right? For first order reaction, we have already derived over here. If concentration increases by 2 times, rate also increases by 2 times. If concentration increases n times, the rate also increases n times. So, it's for a zero order reaction that rate does not change with concentration. It's for a zero order reaction. That's not for a first order reaction, it's for a zero order reaction. So option A, option B, and option D are incorrect, which means the correct option is option C. Option C is the correct answer. Now, what is the difference between average rate and instantaneous rate? So these are actually the two types of rates. So we can just note it down if you want. Please note it down. Average rate. Average rate is estimated. So both are rates only. What are rate? Rate of reaction is changes of the concentration with changes of time. So both these terms actually notate the same, concentration changes with time. But there's a small difference. Average rate is estimated over a wide time interval. A wide time interval. While instantaneous rate is calculated for an instant. It's calculated for an instant. That's it. That's all. For example, let's draw that pictorially. For example, let's say that I have concentration changes with time. Okay? And my plot looks something like this. Like this. It's not linear. It's like a hyperbola. And I take 2 points, A and B. I take 2 points, A and B. So if I have to take the average rate, I'll explain the difference between the two. If I have to take the average rate, what I'll be doing is I'll find the changes, for example. So this is going to be y-axis and this is going to be my x-axis. So I have a change from point A to point B. Let's say this is YA and let's say this is YB. And similarly, I have changes for X as well, XB, and this is XA. So my average rate is going to be very wide. Very wide. So average rate is simply changes of Y, which are huge. Huge changes are written by capital delta. Huge changes in concentration by huge changes in time. Or I can say the difference, YA minus YB divided by XB minus XA, or write it as final minus initial, YB minus YA. YB minus YA divided by XB minus XA is your average rate. So I had taken 2 points which are far apart and I want to know the rate of how the reaction has changed over the time interval from XA to XB. This is how I find. Okay. Now let's say that I want to calculate the instantaneous rate. Instantaneous rate means at any point, at any instant. You do not take a wide range. So for instantaneous rate, you use the symbol small d. Small changes in concentration divided by small changes of time. So this is big delta, capital delta, huge changes, big changes. This is small delta, notating small changes. Okay. So the small changes that happens at point A is taken as the slope at this point, like this. This is called the tangent. I'll draw it again. You draw a tangent. That's it. And you find the slope of that tangent. For B, it's going to be a different tangent. What is a tangent? You draw a perpendicular line. So this is a tangent. And you take the slope of this tangent. You take the slope of this tangent. And that's it. Okay? So this is the difference between average rate and instantaneous rate. Average rate is capital delta changes of concentration by capital T, capital changes of time, while instantaneous means it's just the gradient at a point. How do you find the slope of a line? How do you find the slope of a line? Let's say that I have some slope over here. It makes an angle theta and the slope is tan theta. Very important because questions have been asked relating to this as well. These are our early trigonometry concepts. So this is y, this is x, and if this is the angle theta, slope is equal to tan theta. Slope is equal to tan theta. Okay. So in this portion, in the graph that I have drawn over here, is the rate at point A equal to rate at point B? You can see that the slope of A and slope of B are not equal. Slope of A not equal to slope of B, which means the rate at the point A is not equal to the rate at point B. Correct? Because they have two different slopes. Slope of A is very high than that of B. Correct? So in this particular example where I have drawn, average rate and instantaneous rate are not equal. But see the option. What is the option? The option is average rate and instantaneous rate can be equal. Can be. It's not must be. It is can be. Yeah, it can be equal. When can it be equal? Let's say that this is point A and this is point B. This is my changes of concentration and this is my changes of time. Let's say this is the diagram for the changes of concentration. Now, average rate, of course, you have to take the changes, concentration at A minus concentration of B, time at A minus time at B, and you can divide it. What about the perpendicular tangents? At A also you will get this tangent. At B also you will get the same tangent because it's not a curve anymore. In the earlier section, it was a curve because of which you had to draw tangent. But then this is linear and the tangent will overlap with the line connecting A and B. And in this case, instantaneous rate at A is equal to the instantaneous rate at B, and hence option C is correct only in this case. Option C becomes correct only in this particular case where there is a linear decrease of concentration versus time. Got it? Okay. So revise on this topic, whatever we have learned till now. In next session, we'll start off with zero order reactions. Please write the heading, kinetics of zero order reactions. So no homework. We'll do questions from that as well. Kinetics of zero order reactions. All right. So with that, we'll stop. Thank you, everybody. See you in the next session. Bye-bye.